Hi, and welcome back to Algebra 1. Our goal for today is to continue working with our introduction topics to linear relationships. At this point, we've looked at how to take an ordered pair and plot it in its appropriate location in a coordinate plane. Or if we have an ordered pair, if we have a point already graphed in a coordinate plane, can we identify its ordered pair or its quadrant or axis of location? Please remember, ordered pairs are always in that format of x, comma, y, or how far did we move right or left, and how far did we move up or down comes second. From there, we talked about when we have a linear relationship, which forms a line when we make it in picture format, like this in a graph, right? We have a line. In this picture, it's this line right here going through a coordinate plane. The x-intercept is that place on our line that crosses this axis called the x-axis. The way that we find that is to make our y value 0 in our equation, and then do our math from there to solve for what would be the x until we have an ordered pair that looks something like this. What's the x number, right? That's what we're solving for when our y value is 0. That's our x-intercept. We can also do the same thing for what's called our y-intercept. So if we have a linear relationship, which in picture format like this forms a straight line, right here, this guy right here is our line. Our place where that line crosses our y-axis, our vertical axis, right, is our y-intercept. Or we're solving when x here is 0, what's the y number for our equation or our picture of that particular line? So in picture format, it's pretty simple. I just have to find the correct location. When we're given equation format, we have to replace in values and solve. So when we're solving for an x-intercept, remember that's what means we want to solve for x, which means the other variable, the y, would become 0. If we're solving for a y-intercept, that means we want to know what this y number is when the other thing, the x, is 0. So just be careful. Make sure you're writing the correct ordered pair in the end. Remember that our ordered pair is x, comma, y. So you really have to think, did I make the x the 0 or did I make the y a 0? Make sure you write those ordered pairs in the correct final format. So our goal for today is our other introduction item for a linear relationship, which is called rate of change, which more commonly is called slope of a line. Now, you'll see those words interchanged with each other. What's the rate of change for a particular line, or what is the slope of the line? They both are asking us to do the same exact math. I just have to know that there's two ways to ask that question. What's the rate of change of our line, and what is the slope of our line? And both of those are asking us for what is the number value of the steepness of that particular line? So if we look at two lines, right, we have a red line here and a black line. If we're looking at their steepness levels, this red line has a steeper, right? It's steeper, it's going vertical quicker, right? Which means its slope or rate of change will be greater, or a higher ratio, or a higher fraction. The black line is not as steep, which means the slope or rate of change will be a smaller value when we do our calculations, right? So we were looking for a description here that describes that steepness, which is how far did we have to travel upward compared to how far do we have to travel over, right, side to side to get to a new location on our line. That ratio of how far up compared to how far over gives us our slope or rate of change. When we do those calculations, we have 4 different types of results that we could get. I apologize here about the formatting. The E got bumped down there. All right, so type number 1, what's called positive slope. Type number 2, which is called negative slope. Type number 3, which is called zero slope. And type number 4, which is called undefined slope. So looking at our types of slope, let's go for a little hike. All right, so we're going for a hike around this mountain. So the beginning portion of our hike, which is going to be this portion, right, heading sort of up towards the top of our mountain, right? Our hiker gets going here. Oops, excuse me. Let me get my erase out. I just put a big streak on my hiker. All right. So our hiker starts out down here, and he's going to head up towards the top of this mountain. Now, even if the mountain was steeper like this, right, going this way, or a little bit flatter going this way. If you're starting low and heading towards the top of the mountain, right, that's type number 1, right, up the mountain from low to high, then we have what's called positive slope. All right, that's option 1. All right, option 2, I'll add in, right, is sort of this top of the mountain portion. All right, so once we get at the top, right, we usually just sort of like stand here and hang out, or what you would think of walking completely on a flat line, right? I think of it as like, ooh, I'm at the top. I'm going to do nothing for a while. I'm probably going to get to the top and rest and relax, right? So once I'm up here, I'm doing 0. So if we're at the top of our mountain on a flat horizontal line, that's called 0 slope. All right, part number 3 of our hike will be this trip coming back down, right, down the mountain. All right, so once our hiker starts coming down the mountain, starts high, right, and works down low, like that, right? That's our trip down the mountain, and that is negative slope. And then we have this sort of special case over here, right? Straight up and down vertically, which is part number 4 of our hike, right? Which is if this hiker goes, crash, boom, splat, right? We fall down here at the bottom, kaboom, we went off the cliff. That's undefined slope. Right, where we crash, burn, and explode at the bottom, undefined. All right, so a couple little baby pictures here to look at. Right, if we follow it, we're reading it like a book. Start as far left and work to the right as possible. So as far left on our line, right? This one would be we're going up a hill, right? I'm starting low and I'm heading up a hill. Same thing here. I'm starting at the bottom and I'm working up a hill. So these would be examples of positive slope. All right, this next one, if we start as far left as we possibly can and work to the right, we'd be going down the hill, down the hill. That's an example of negative slope. All right, we're on the top. We're just hanging out up here on the top. When we're on the top of the mountain, we're doing 0. That is 0 slope. And when we go kaboomy, because we go splat, right, that's our undefined, right? We fall off the edge of the cliff here. That's our undefined slope. So as we work through our calculations today, there's 4 different types of answers we could get. Is our final slope value, our number, a positive number when we simplify? Is it a negative number when we simplify? Does it have a value of 0 when we're done simplifying? Or is it an undefined scenario? And we'll look at what causes that. So our steps for today, how to calculate the rate of change, which is our steepness or our slope of our line. All right, to be able to calculate that rate of change on our line, we need 2 points, and it can be any 2 points from our line. So sometimes we'll just be given those 2 points, which makes things pretty simple. But sometimes we're not just given values, right? We might be given a picture of the line where we have to gather 2 points ourselves, or we may be given a table of values of some of the points on a line, and we can use any 2 points. All right, any 2 locations on our line will help us get our rate of change or slope of that line. It doesn't matter which 2 points you use, because when you're done simplifying, it should give you the same exact slope or steepness amount or rate of change amount. So once you have your 2 points identified that you're going to use, your slope formula is m equals the difference of our y's from our ordered pairs. So don't be confused here. We see these little like 1s and 2s here. This just means what's the y from our first ordered pair, right? And this 2 just means what's the y, right? Because we're always x comma y, right? From our second point. Again, down here, x2 and x1 are, what are these x's from our 2 points? Now be careful, the order does matter of how you replace in. These 2, x and y, have to be from the same ordered pair, and these 2, x and y, have to be from the same ordered pair, so just be careful. All right, once you replace in, you're not allowed to have decimals here and you're not allowed to have mixed numbers. It is a ratio. So you have to have a simplified fraction. Sometimes that means your answer will stay as a improper fraction, which means the top number bigger than the bottom. So we have three ways we can think about slope or rate of change. M equals delta y over delta x, right? This little triangle called delta really just means what's the change in. So, right, that what's our slope equals the change in our y's over the change in our x's. So this middle block, which is the formula we're going to be using today, is sort of this block expanded out a little bit, right? The change with this triangle, which stands for the change in y, would be our two y values being subtracted. And this delta down here is the change in our x's, which would be the subtraction of our x values. All right, so we're going to be using that one today. Now, the other sort of shortcut way of thinking about slope is what's our rising amount compared to our running amount? This version, this last version, helps us a lot when we start to use slope as a tool to help us graph the picture of our solutions. So our goal for today, using our slope formula to help us get our final slope or rate of change amount. Now, remember, there are four different types of answers we can get. So option one is we end up with a positive or a negative or a negative. And when I go to simplify, I need to use my integer rules from way back 6th, 7th grade. A positive divided by a positive or a negative divided by a negative will always simplify to a positive amount, right? So that's going to be representing our lines that are heading up the mountain, right? These are our lines where our hiker starts low and gets high. All right, if we end up with a positive divided by a negative or a negative divided by a positive, that represents our answers that are going to simplify to negative slope values. Or those slopes or those rate of changes represent that hiker coming down the mountain. Now, scenario number 3, I have a 0 on the top. All right, here's your shortcut. If 0's on the top of your fraction, it's like we're on the top of the mountain. When we're on the top of the mountain, that means we have 0 slope. And our simplified version would be a 0 over 1, right? Because we need a ratio here, right? So 0 over 1 is our simplified version of 0 slope. And it's when 0's on top. It's when our hiker's on the top, right? That's when we'll have 0 slope. And then our special case here where we have our fraction, but 0's on the bottom, that's like we're on the bottom of the mountain, right? We fell off the mountain, right? Kaboomy. That's our undefined slope. And there's actually no number to represent that because if we can't have 0 in the denominator, and that's what causes that undefined value down there. So just be careful. So 4 scenarios. Positive slope, negative slope, a 0 over 1 slope, and an undefined slope. Now, there are 2 sort of things that help us identify sort of these bottom 2, where we get 0 on the top and 0 on the bottom. That might help us, which is if our y values are the same in our ordered pairs, our slope will end up simplifying to 0, or more specifically, 0 over 1. If our x values in our order pair are the same, then when we simplify, we'll get the final value undefined slope. All right, so let's look at some examples. We're going to be using this formula. M just stands for slope, equals our y2 minus y1, or our y from one of our points minus our y from our other point over our x from our original point minus our first from our other point again. All right, so problem number 1, we want to calculate the rate of change, which is also a way of saying what's the slope or steepness of a line that passes through one point, which is at the location 1, 5, and a second point of -2, 2. So my suggestion to you is to assign which one you're going to call point 1 and which one you're going to call point 2. That'll help you when you go over to your formula substituting things in. Again, it doesn't matter if I put 1, 5 here, which is going to be our x1, y1 when we go to replace, which are these 2 right here. That means I have to use -2, 2 here. Now, I could put this -2, 2 up here and the 1, 5 down here. It's not going to change anything once we do our simplifying. All right, now that I have an idea of what I'm putting in for x1, y1, x2, y2, right? We've assigned x2 is this -2, this y2 is this +2, and so on. We're going to substitute into our slope formula. So M equals, which stands for slope equals. Our y values on top. So I'm going to go to my y2, which we just called a value of 2. Don't forget it's subtraction here. And then our y value, which is the top y, which is a 5. All right, now we got to go in that same order. X2 we called -2 minus our X1 we called +1. All right, now we're going to do our subtraction. So 2 minus 5 would actually give us a -3. And then -2 minus 1 would also give us a -3. Now, there's two things I have to do here when I'm trying to get my most simplified version. The first part of my simplifying should be, can the sign on these numbers be simplified? So I'm going to ignore the numbers and just think about the signs. A negative divided by a negative gives us a positive. So my final step down here, my final one, has to be a positive. And then I'm going to go to the numbers and say, a 3/3, can that get reduced? And it absolutely can. If you're not sure how to reduce that, use your fraction button on your calculator, not your divide, right? We need no decimals and no mixed numbers. So be careful. So 3, ABC fraction button, 3. And we end up with a +1. So our fraction would actually be 1/1 in simplified version. So all that really means is when we go up 1, we also go to the right 1 to land back on our line for this case. A rise up 1, run out 1 gets us back to our original line. All right, let's try another one. Number 2. I want to find the rate of change, which can also be called slope, of the line that passes through the points -3, 6. So I'm going to call that point 1, -3, 6. That's going to help me. Those are my x1 and y1, right? x1, y1. And I'm going to call this 4, -5, the x2 and y2. All right, now that we've assigned what's going into where in our formula, y2 minus y1 over x2 minus x1. All right, so let's do our subtracting. -5 was our y2 minus our 6. Don't forget, it's always subtraction in between there. We're finding the difference of our y's and our difference of our x's. So our x2 we called 4 minus our x1, which we can see is a -3. Be careful here, there's a subtract and a negative. All right, do our subtract and then think about if we can simplify. So -5 minus 6 would give us a -11. And then 4 minus -3 is the same as saying 4 plus 3, right? If we did keep change to it, that'd become plus positive, and we get a 7. All right, from here, we need to do 2 checks. Can we simplify the sign, and can we simplify the number? If we can do any simplifying, we're going to have another step. So a negative divided by a positive will always give me a negative. So having a negative sign here is the correct sign. So the sign can't be simplified. So I go to my fraction part next. If I'm not sure if 11/7 can be simplified, remember, no mixed numbers. I would do 11, my fraction button, which is the ABC button we've been using on our calculator all year, 7, enter. It's going to give me a mixed number because right now it's improper. So I'm going to hit the second button and then ABC, and that'll give me back the simplified but one big improper fraction. If it gives me back 11/7 again, then we're already in the most simplified version. If it gives me back something else, it's the more reduced but still improper version of what's there. In this case, -11/7, the sign and the number can't be simplified, but make sure you check everything is in its most basic simplified version. So what does that really mean? So this -11 means if I start at any point on my line and I move down 11, and then from there, the +7 says, then go to the right 7, right? If I do those two movements, down 11, right 7, I will end up back on the original line. And since it's negative, we know in the picture version, it would be a down the mountain line, right? Our hiker would have to be coming down that mountain. All right, number 3, we want to calculate the rate of change or the slope of the line that passes through -3, 7 and -3, 1. So I'm going to call this guy -3, 7. I'm going to call my 2's -3, 1. Again, we can have those flip-flopped, right? The -3, 1 can be on the top, -3, 7 can be on the bottom. It'll give us the same final simplified answer in the end. All right, subtracting our y's on the top. So y2 is 1 right here. Y1 is right here, right? This is y1 right here. It's -7. All right, do the same thing with our x's. So negative 3 minus a negative 3. All right, do our subtract and see if we can do any simplifying. So 1 minus 7 will give us a negative 6. Negative 3 minus negative 3 is the same as saying negative 3 plus 3, which would give us a 0. All right, we got one of those sort of special cases here that has a 0. Remember, 0 on the bottom means our hiker is at the bottom, right? Kaboom, he fell off the cliff. When hiker's on the bottom of the mountain, which would be a line that's straight, vertical, up and down, we don't have a number to represent that, so we have to write the word undefined slope. Just be careful. It's the only one when we're calculating that we'll actually give a word to, because we don't have a number that can represent undefined slope. All right, number 4, we want to calculate the rate of change or slope of the line that passes through the points 7, 8 and 3, 8. Again, I chose to call these two my 1s, right? And these guys are my 2s down here below. All right, so m equals y2 is 8 minus y1, which is also 8, over our x2, which is a 3, minus our x1, which is a 7. All right, let's do our subtract and see if we can simplify. So 8 minus 8 would give us a 0. 3 minus 7 would give us a negative 4. All right, again, we have a scenario here where there's a 0 involved, and it's the ones we're going to tend to mess up on. So 0 on the top is different from 0 on the bottom. This last one, the 0's on the bottom, which meant our hiker was on the bottom of the mountain undefined, right? This one, the 0's on the top, which means our hiker's on the top of the mountain. When we're on the top of the mountain, which is horizontal, then our slope is 0, and more specifically 0 over 1 when it's in its most simplified basic version. All right, you try your 5 and 6. What's the slope or the rate of the change of line that goes through 11, 2 and 7, negative 5? And what's the rate of change of the line that passes through 3, 7 and 8, negative 3? All right, hopefully you've done your on your owners. Let's look at them. All right, I chose to call 11, 2 and 1 point number 1 and 7, negative 5 my point number 2. But again, if you had this up here and this down here, this step and this step would look a little bit different, but this final answer would still match up. All right, so it's not going to mess you up. So negative 5 minus 2 over 7 minus 11, or you could have 2 minus negative 5, and I'll show you, right? My other option is the other way, right? 2 minus a negative 5 over 11 minus 7, right? So this version, the first version, the one I did, gave us negative 7 over negative 4. This version would give us 7 over 4. This one's done. It doesn't need simplifying. And this one, when we simplify, a negative over negative is a positive. Again, we'll see that these both give us that rate of change or slope of 7 over 4. Or if we rise up 7 and we run out to the right 4, we'll end up back at a new place on our line. All right, number 6. Again, I chose to call 3, 7 point number 1, 8, negative 3 point number 2. But again, I could have these two flip-flopped as we just saw. It's not going to change our final simplified answer. So in the end, when we're done reducing, we should have a negative 2 over 1. Remember down here, we should have fractions. So when I end up with a whole number, I need that 1 on the bottom. We need a ratio or a fraction when we're done with our slope. We want to know what's the difference of our y's over that difference of our x. So make sure we're including that. All right, I hope that helps you attack your work for today. See you guys later.